Welcome back. We're continuing on with section 2.2.3. We're going to do some more additional problems. So once again, for number 8, we're going to multiply everything by the common denominator. And that least common denominator is going to be x minus 2. So now we're going to multiply each term by x minus 2 once, twice, 3 times. So I can write that out a little bit bigger. So it's x minus 2 over 1 as a placeholder times 5x over x minus 2 equals 7 times x minus 2, don't need the placeholder there, plus 10 over x minus 2 times x minus 2 over 1. Now in the first terms, the x minus 2's cancel. We're left with 5x equals, distribute the 7. We get 7x minus 14. And the x minus 2's cancel, so we get plus 10. A much nicer looking equation. So now we're going to combine like terms. So 5x equals 7x minus 4. We're going to subtract 7x from both sides. Negative 2x equals negative 4. Divide both sides by negative 2, and x equals a positive 2. Now remember, we want to check when we have x in the denominator. When we check, 5 times 2 over 2 minus 2 equals 7 plus 10 over 2 minus 2. Now I see I have 10 over and 2 minus 2 is 0. As soon as I see that division by 0, that's undefined. And as soon as I see undefined in my check, I can throw away this answer. X equals 2 didn't work. Now, that was my only solution. It didn't work. So what I have here is I have no solution. There is no value for x that would never make that equation true. There's no solution. Remember, this is where the two graphs will intersect. These graphs will have no point of intersection. So don't forget to check for extraneous solutions. Now, in problem number 9 on the next page, we're going to look at, are these equivalent? So what I'm going to do is I'm going to take this equation and rewrite it in that slope-intercept form. So 6x plus 3y equals 12. I'm going to subtract 6x from both sides. 3y equals negative 6x plus 12. And then divide each term by 3. So y equals negative 2x plus 4. And there you go. You can see they're the same exact equation, so they are equivalent. They're equivalent expressions. Now we're going to rewrite so that it's in y equals form. So now we're going to get this in the slope-intercept form, or almost a variation. We're going to solve for y. We're going to get y in terms of x. I'm going to start by subtracting 5x from both sides. Negative 2y equals negative 5x plus 8, and then you divide each term by negative 2. So we get y equals, negative divided by a negative is a positive 5 halves x, 8 divided by 2 is negative 4, so minus 4. And there is our equation in y equals 1. I'm going to skip to problem number 12. Do the same thing. I'm going to add 3x this time. So I get 4y equals 3x plus 17. Divide everything by 4. Y equals 3/4 x plus 17 over 4. You can leave it just like that. There's y in terms of x. Now, I skipped 11 and 13 because they're a little bit more difficult. These are more Algebra 2 problems. You can see we have x in 2 spots. So what we can do is we can start by factoring out an x on that left-hand side. So it's x times the quantity of y plus 3 equals 2. Now our goal is to isolate the y. So I'm going to divide both sides by x to undo that multiplication. So we're left with y plus 3 equals 2 over x. And then to get y by itself, we subtract 3 from both sides. Y equals 2 over x minus 3. And there's our equation. with y in terms of x. Now for number 13, we have x for both of those first two terms, we can factor out the x. It's x times y plus 2, and that equals 14. To get y by itself, divide both sides by x. Y plus 2 equals 14 over x. And then subtract 2 from both sides, so y equals 14 over x minus 2. And there's our equation of y in terms of x. We are going to stop there for section 2.2.3, and that is the end of chapter 2. Thank you. Have a nice day.